Hello, 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 everyone. Today we are going to look at the graph of a function and answer some questions about it. So let's get started here. The first thing I want you to notice, f of x represents your output, which is also your y. So x of x is your y coordinate. All right, I want you to remember that. And your input are your x coordinates. So in number 1 here, where it says f of x equals 0, another way to say that is y equals 0. So when I answer this question, I want to know where y is 0. And if you remember from other math classes, y is 0 at the x-intercepts. So wherever the graph crosses the x-axis, y will be 0. So right here, and right here. So this goes over 2, up nothing, over -2, up nothing, and so on. So our input values will be 2, and then -2, and 2, 3, 4, 5, 6, -6. So when we input 2, our output is 0. When we input -2, our output is 0. And when we input -6, our output is 0. That's what that tells us. Number 2, it says f of -4. So they're telling you to input -4. So you have f of x, they change the x to -4. So they're telling you when you input -4, so when the x value is -4, what is your output, your y value? So let's take a look at our graph again. So we want to look at where x is -4. 1, 2, 3, 4, right here. And we want to bring that down to our graph. So when x is -4, what is our y value? We got -4, comma, and it goes down to -2. -4, oops, I don't know why it's doing that. -4, -2. All right, let's erase that here, make it look a little better. -4, -2. Well, it's not gonna let me put it there. All right, so when I input -4, the output is -2. That's what it tells me. When I input -4, the output is -2. Let's take a look at the next one. It says the output, which is our y value, is -3. What is the input? So if I go down to -3 on the y-axis, I'm right here. Does the graph even go that low? No. So the output won't exist. So if the input, excuse me, if the output is -3, the input does not exist. Go down to -3 on your graph. Take it over. The graph does not cross at -3 anywhere, so it doesn't exist. Now, just a refresher on how I know that this graph is a function. We just have to do the vertical line test. Just keep making vertical lines to it. The goal is to try to make those vertical lines cross the graph more than once. But because it doesn't, this is a function because it passes the vertical line test. So yes, it's a function. Use the vertical line test. It crosses only once wherever you put the line. Your goal is to try to make it cross more than once. But if it doesn't, then it's a function. So let's take a look here. Let's erase this, clean it up a little bit. Next, we're going to take a look at the domain and the range. Your domain are your input values, your x. The range are your output, your y's. So we're going to take a look at how far left and right this graph goes first of all. How far left and right. That's for my domain, x-axis. There's the farthest left, there's the farthest right. So the farthest right is 2, the farthest left, -1, 2, 3, 4, 5, 6, -6. So the domain is -6 is less than or equal to x, because the x coordinate is our domain. which is less than or equal to 2. Or you can write it in brackets, because we're including the -6, and we're including a 2. You can write it like this. If we weren't including them, then we'd use parentheses. All right, let's take a look at the range. How high and low does our graph go? How high and low? Here's the highest point. Oh, it's just a different color. Here's the highest point, and here is the lowest point. So lowest point is -2, and the highest point is 2. So our range is -2 is less than or equal to y, because that's our range, which is less than or equal to 2. And we're including both those numbers, so we can put it in brackets and write it like this also. All right, let's take a look at one more problem. Just one more. All right, we have a graph here and we need to answer these questions. First of all, is this a function? If I perform the vertical line test on this graph, is it a function? Take a second and do it. Remember, your goal is to try to make that vertical line cross somewhere on the graph more than once. If you can't, it is a function. In this problem, you will not be able to make it cross more than once. So yes, it is a function. Every x has a unique y value. This time we're going to start with the domain and range. So our domain again is how far over it goes left to right. So the farthest point is right here and right here. So from 0, it's over 1, 2, 3. And the other direction, -1, -2, 3, 4, 5, 6, 7, 8, 9, -9. So our domain, again, which is our x, is from -9 to 3. Always put your smallest number on the left and your bigger number on the right. Then you can use less than or equal to symbols. If you're including the -9 and including the 3, you use less than or equal to. If it had an open circle here, then you just use a less than symbol, but it doesn't. All right, another way you can write that, we're including the -9 and we're including the 3, so we'll use brackets. If we weren't including one or both of them, we'd use a parenthesis on that side. All right, let's take a look at our range. How high and low do we go? So how high and low are we? Let's find another color here. So the highest point is right here. The lowest point is here. Remember, you look at the whole graph, the highest point in the whole graph, the lowest point in the whole graph. The lowest point is at -1. The highest point is at 2. So our range is from -1, less than or equal to, because we're including it. Range is our y values, which is less than or equal to 2. Again, smallest on the left, largest on the right, then you can use less than symbols. We're including the -1 and we're including the 2. So you can also write it like that. Let's take a look at the next one. It says f of 1, f of 1. So that tells us our input, we're inputting 1. So we're replacing x with 1. So I want to go over on my graph and see where x is 1. X is 1 right here. So follow that up on your graph till it touches your graph, and it touches that 1. So when I input 1, the output is 1. Input 1, the output is 1. Right there, 1, 1. All right, let's take a look at the next one. Now they're asking you to input -3. So our x value, our input is -3. So go over to -3 on your graph. On the x-axis, 1, 2, 3, that puts us right here. And then follow that down to your graph. When I do that, I get -3, -1. So when I input -3, the output is -1. Now be careful on the next one, because the next one doesn't give us the input value, it gives us the output value. So you gotta be really careful on these. So they're saying that when y is 2, Remember, f of x represents y. So when y equals 2, what is x? So I want to look at the y-axis, go up to 2. Just make a line across there if you need to, so you don't miss any of them. So when y equals 2, I have two different values for x. So I'm going to write them separately. When y equals 2, look at this one right here, x is 0. Also, when y equals 2, oops, I gotta wrote that backwards. When y equals 2, x equals 1, 2, 3, 4, 5, 6. Negative. So go over -6 up 2, and there you have it. You just have to remember the f of x represents the output, your y value. So in the last one, it says y equals 0. If y equals 0, you're looking at your x-intercepts. Where does the line cross the x-axis? It crosses it right here, right here, right here, and right here. So if you input 2, your output will be 0. If you input -2, your output will be 0. If you input -4, your output will be 0. And if you input -1, 2, 3, 4, 5, 6, 7, 8, -8, your output will be 0. So the big thing here you have to understand is that the f of x represents the output and the x represents the input. If you can get that down, this isn't too bad. All right, have an awesome day.